Hi and welcome everybody. I'm Carlo, this is Fabian, and today we are here to speak about functional-reactive programming for developing enterprise applications. Before we get started, please be reminded that you can vote for the sessions on the app, and please do so. Okay, when we first showed up at Scala conferences about a year ago, and ever since, people, when they approached us, were very surprised to find sub-persons at Scala conferences, which is why we dedicated the first 10 minutes of this talk to give you a little context on what we are doing at SAP with Scala and how this functional reactive library, which Fabian is going to explain afterwards, fits into this project. Okay, so what is SAP doing with Scala? SAP is a very large company. There are huge slide decks which I could show for 30 minutes, which would show you funny facts about how 82% of all the coffee which is produced worldwide is produced by SAP customers. Don't worry, I'm not going to do that. But what you should keep in mind, it's a very huge company. It's about 85,000 employees right now. And they have such a huge customer base because of their core product, which is an ERP system. So an ERP system is essentially a piece of software which manages all your business processes, which means whenever somebody in your company decides to buy something, he'll do that through the ERP system. He'll trigger a process to buy this thing. Whenever you send an invoice, you'll do that through the ERP system. So the ERP system is kind of responsible to keep track of all the things which are happening in your company. Okay, so that is not the correct slide. That is very unfortunate. Okay, then I'm going to improvise. Okay. So traditionally, these ERP systems are written in ABAP, which is the house language of SAP. So these interfaces, usually they had a front end, which was called SAP GUI. It was something which is similar to an RDP client. So you could have an expert user sitting in front of there. He would type in some magic numbers for general ledger accounts and other things I don't understand fully. And then if they did all right, they could click the Go button. A query would be triggered to some backend. The result would come back. And then the information which was requested would be shown. Of course, there are not only analytical applications, there are also transactional applications. For instance, if you want to post specific business orders and start specific things. Okay, so unfortunately I can't show it now because the slide is missing. So imagine there's this picture of the old user interface sitting there, and it's not really, it doesn't look modern. I mean, this ERP software was first introduced in 1993. It's seen multiple iterations. But still, the last iteration wasn't nice, so people said they want to have a front end which is focused more on the user, so to give the user a better user experience. Then they came up with front ends which were actually executed in the browser, so web front ends. These web front ends, I'm not going to say that they look amazing, but they are a significant improvement over the old state. And this transitioning process from the old SAP GUI frontends to the web frontends is a very huge task. That's mainly due to the scale of the ERP system. So just to give you some numbers, it's insanely large in every dimension you can imagine. So the table width of SAP tables can span up to 350 columns, and that's pre-customization, because usually customers will go and extend the data model, they'll add additional columns, then you can have as much as 500 columns per table, which poses a challenge to many things you could try in order to manage these tables. In addition to that, you also have quite many tables. So for instance, the system we use for debugging has something like 126,000 tables, which is intense. And then you also have very many applications. So the ERP system consists of something like 10,000 applications, which are all very specific. For instance, you can post a purchase order, you can manage purchase orders, you can list purchase orders. And all of these are specific applications which have to be coded somewhere. Okay, so knowing that, in addition to this, there's also this transitioning process towards the cloud. And SAP is operating this sub-cloud platform. It's not really important, but the cool thing about this is that they actually opened up the kind of programming languages they would allow. So there's Java, there's Node, and our idea was essentially, okay, let's have a look at these applications. So I mean, this application, this is a web front end, how it's currently looking, more or less, currently at least. So there's not much which is really specific to this application, right? I mean, there's this head bar, which looks like a pretty generic head bar for an SAP application, which has the title of the application, some generic controls to navigate home, to go to your user profile, and all this stuff. And then there's some filter control, which allows you to type in the general ledger account, for instance, or your company code, and based on the values you enter, you can then see some data which is in the table underneath that. And one of my colleagues had a look at this and said, how hard can it be to write such an application? I mean, this application should be writable within, let's say, 20 lines of code. That was a very bold claim. And we ended up experimenting with different languages, tried different things, wrote a prototype in Scala, which actually was pretty successful. So by the time last year for Scala Days in Berlin, we had the project funded to build this into a platform which is usable on the cloud platform, and that's how our code is currently looking. So I know it looks kind of funny to most people, especially because the first line is already macro invocation. Okay, you don't have to understand macros, but I'm briefly going to explain to you how we envision this code should work at some point, or works for this specific example at least. So this add marmolata client thing is a macro which injects some client server logic into the demo object, the demo app object, which is in line 2. So it's mainly responsible for ensuring that we can issue queries to the backend. Exactly. Let's jump ahead and go to line 11. So line 11 is something which is really nice. It's the part of the application which will be rendered. So it says, please render the filter above the table, which is exactly what is displayed here, right? It's some filter control above some table control. So it has to be written somewhere in the source code. Okay, the definition for the filter control is actually in line 5, and you can see that we say the filter control should essentially be something which it has a data source, so we create it for a data source, and the data source is a query. So the query itself, of course, has to be defined somewhere. This is happening in line 3 here. You can see that we use another macro, which actually allows us to write SQL in our source code to expose a very simple user interface to which most of our programmers are already familiarized. Okay, then if we have a look at the semantics of this application, what we would expect to happen is essentially when somebody filters for some company code, that the data in the table gets adjusted accordingly. So this is also something which we have to write in our source code. This you can see in line 9 when we define the table, that it should actually take the output of the filter bar as its own data source. Okay. If somebody would stand here in my place, and I would be sitting somewhere in the audience, I would say, this looks kind of unbelievable, I don't trust you. And it's not the full truth, I haven't told you everything yet. So, of course, we also have some server code. It's pretty boring. It's essentially a plain object with the server annotation, which is corresponding to the client annotation in line 1. And this is the default Scala.js cross-project compilation pipeline. There's some client code, there's some server code, there's some shared code. We use the Scala compiler to compile the backend. We use the Scala.js compiler to compile the front end. And in addition to this, there's more. Because if I go back to this thing, I see, for instance, that all the input fields have correct labels. It says company code here. And if I look at the table, there's also correct labels like posting date. If I look at my source code, I can't see them anywhere. This is because they are coming out of a metadata store. So SAP operates metadata stores of these 120,000 tables I mentioned earlier. They don't all store customer data. They store configuration, they store labels, they store information on what kind of value helps you would expect to show up if a customer types in a string into a specific search field, and all of these things. So we leverage those at compile time. So whenever we actually compile against the database, we do this. This also applies to the SQL macro which we have. For instance, when we have this column, we fetch all the information for the columns and compile this into our code and leverage this information. So going back to this example, there's one thing missing, because what of course has to happen is if I click this Go button, the table has to update. That's quite obvious from the semantics of this application. And this is also not specified somewhere here in this code. And for that, we use functional reactive programming, and Fabian is going to tell you how that's working in detail now.
Hey, so I'm Fabian. So I'm going to concentrate a little bit on the Marmolata UI part now. So Carlo has told you about how this whole project looks in general, and I'm concentrating on the front end now. So what are we doing in the front end? We are using Scala.js because we like that Scala.js is typed, and we like all the Scala features. We want to reuse them, and also we want to have a common language for both the front end and the back end. Also, we are using SAP UI5. UI5 is a JavaScript library for UI controls from SAP. It is also open sourced, and yeah, it provides, for example, this table which you see there. So this is a screen of Marmolata UI5 of UI5 application, not the Marmolata one. And it provides all kinds of controls that you might need in the SAP context. And so we want to have that. And what we did is we wrote a wrapper for Scala to be able to use this. Also, we want to produce code. We don't want to write too much code to write these UIs. And it turns out that a lot of code, so research has shown that a lot of code that is problematic in the UI is the event handling. A lot can go wrong. And yeah, there's also this claim that half of the bugs reported during a product cycle in some specific applications exist in the event handling logic code. And that's why we want to leverage functional reactive programming. And that's what I'm going to start with in the talk. I'm going to talk about what is functional reactive programming. Then I'm going to make a demo for functional reactive programming with our library, which we just open sourced, Marmolata Dive, and together with UI5. Then I'm going to compare it to some other libraries in the Scala context, because disclaimer, we didn't invent functional reactive programming. It's actually a known concept for a while. But as a beginner talk, we are going to show what functional reactive programming is about here. And then we'll finish off with questions. Okay, so what is functional reactive programming? So we all know, or at least we really like this functional programming, where you try to make the side effects as late as possible. So to stay in this functional system as long as possible, so you can better reason about your programs. And functional reactive programming takes this a step farther. So the problem, even if you use functional programming, then maybe in a UI you have some button, and whenever that's clicked, okay, the side effect has to go on. We can't avoid that side effects happen there, so we can't make the whole application as a function. Functional reactive programming tries to abstract also over the time, or tries to capture the time in its variables, so that we can have functions that also change over time. And how does it do this? So it does this by explicitly modeling dependencies between values and then automatically propagating the changes. So let's look at an example how this works. Okay, I always forget the slide. So there's related work, as I already said. So especially in the Scala work, there's the paper Deprecating the Observer Pattern with Scala React from Ingo Maier and Martin Odersky, which presents in detail how this functional reactive programming in some specific way can avoid bugs, and it has a prototype implementation, Scala React, of this. And there are also other libraries that provide functional reactive programming principles. So who of you have used Scala RX before? Okay, that's good, not so many, so I'll explain then in detail about. So Scala React, okay, interesting. So for you, this will probably then not be so much news. Okay, let's continue. Okay, let's say we want to model some data in an application, and we have, for example, some value in an application that we want to have there as a variable that changes over time. So what we would usually maybe do in a Scala program is write something like x equals to 10, var x equals to 10. So it already uses this var, which some people discourage in the Scala, but well, we have to have a value that changes over time, so what can we do? So when we use it in the functional reactive programming context, what we do is we wrap this and we write instead while x is var of 10. So what does this do? So this blue circle represents a signal. And this while x is now a signal. And the signal is basically this integer. So it's a signal of int. It's basically an integer, but it is wrapped in some box, kind of. And then the functional reactive programming library can use all its power to make this work, to have some advantages when you write it like this. So then you may have some other value in the program you want to compute out of this value. So like, we could compute it out of this value. So as an example, let's take an addition of 1. So when you would have written var x equals 10 there, then what you would then write there, of course, is y is x plus 1. So nothing fancy. Because this is now wrapped in this box, we can't do this. We can't just add, say, while y is x plus 1. So instead, what we have to do is we have to say, okay, y is x.map underscore plus 1. So this map gets this value out of this box, and then there we do the calculation, and So now let's say this x value changes. So we could, for example, say we change it to 15. So what happens then is that the 10 is updated to 15. So note that we don't use the x equals 15 here, but we use colon equals 15. So that's a function of this variable, of this var type. So then this updates to 15. And what also happens is now that this dependent value is updated to 16. So when we would have written this with this while, then that would not have automatically happened, right? And we would to have some code maybe to do this, or we would have to write it as a def, which also has its disadvantages. So here we just get this benefit that this is automatically updated. Okay, so maybe there's also another dependency, so as in just what other computation can there be? So let's take -1. So maybe this is 14. Okay, we calculated, we now already know how to calculate this, so we do again x.map underscore -1. Underscore is this function syntax in Scala. Okay, and now we want maybe to compute a value out of these two other values. So in an application, you could easily imagine that some value has to be computed as different other values in some chain, and there's maybe a complicated like dependency graph in there, and this is then here managed by this system. So let's say we want to add these two values, and then we get the value 30. Okay, what do we have to write there? You first have to say what kind of values you depend on. That's basically y and z. And then you have to say, okay, what kind of operation you want to do. And this is again done with a map. And then you say, what you want to do, and which is in this case an addition. Okay, and now we can see in this a little bit more complicated example than before what happens when we update this value. So let's update the value to 16. So what happens? Then these values are all updated. So after each other here in this diagram. So and what we can see here is now what could happen. It could either happen that the 30 is now updated, the added. So when this would update now, it would update to the value 31. But this would not be right, because in no case, in no time in this program could this value have been 31. So what actually happens is that first this is updated to 15, and then the 30 is updated to 32. And this is a really important feature for us for this functional reactive programming that is called atomicity, and it means that these values are all updated at the same time from the observer perspective. So this has this feature that really multiple things can happen at the same virtual point of time. So what does that mean? So at all observable times, of course this library does some stuff internally, so maybe then it won't hold, but at all times you as a programmer can reach this value. These equations, which are modeled by these maps, really also hold. At least we have strong guarantees for that. I mean, proofs are always hard. Okay, what does it mean? So this added .now. So .now means it's the count value of the signal. So these signals always have a count value. It is what we wrote down there, x.now plus y.now, and when we transfer this farther back in this tree, we get x.now plus 1 plus x.now minus 1. Okay, actually in our library, and also in the Scala React implementation, we don't only have signals, which I shown in this previous example, we also have events. Events are similar to signals, but they don't have a value at all times. So when you in the down of this slide, you see two graphs, one for how you can represent a signal. So both represent in the x-axis the time and in the y-axis some value. And you see the signal at each point in time has a value, and the events as a difference, the events at specific points in time happen and then have a value, but only for like an infinitely small amount of time. Okay, and then, so up until now, I've told you how you can produce these signals and maybe also events and how to map them to new events or signals, but then at some point you want to do something with these signals. So maybe you want to display them in a UI, or whenever a signal changes, display some dialog box or something like that. So, I mean, everything is nice inside the system of this functional reactive programming. So staying inside the system means that you keep staying in signals and so on, and then you have this atomicity guarantees, but at some point, you want to see something. So this is similar to, not your whole program can just be a function, but at some point you have to do side effects, otherwise just electricity bill or something like this. Okay, so this is the observe method on a signal or also on an event. You have this observe method, and with that you can then actually do a side effect. And the side effect always happens when the signal changes or the event is triggered. Okay, so as I said, so I'm presenting currently the flavor of our Marmalade Dive library of this. So I already introduced these concepts of signal and event. So signal and event are these things that you can't set directly if you only have a signal, because it is like set how it depends on other values and so on. So we have this kind of first introductory signals like var. So in a var you can also set the value, and then later in other signals you can depend on other signals. And the event source is similar to that in the event scope. And we also have a reassignable var, which comes later into play. Okay, and when you look at the functions, so a signal, of course, has this now method, which is kind of this, the signal always has a value. And then they also have all kinds of functions, and you can really look at them similarly to a sequence. So a signal is kind of a sequence over time a sequence over time. So to, for example, add some value to this value inside the signal, you have to do the same as you would have also to do in a sequence. When you want to add 1 to every value in the sequence, you have to call .map, and here we have to do the same. So this is similar in that regard. So I've talked a lot theoretically now. Now let's get a live demo of this. Okay, so I prepared here some app. So we want to create a voting app. So actually we want to create a UI5 application. So I already written down here the UI part of the application. So we may have a yes button, and then maybe there could be some info displayed next to the yes button. And then we have a no button, with which you can vote no, and also the no option, and maybe then the checkbox, which you can check to display the results. And then we have here the render method, which Carlo also already shown. And here we just say how we want to display this. And now we can execute this. So we see here this is kind of a simple browser that just has a front end. And so this is the app. We didn't care about the CSS at this moment, so it may look a little bit ugly, but we're okay. So nothing happens yet, but what we want to do now is we want to, whenever you click yes or you click no, we want to save the information how many votes were voted. And then maybe also when show results is clicked, we want to show these results. So how do we do this? So first of all, in the header of this application, we define what kind of values we want to have in this application. So what kind of signals we want to have. So and we want to have the number of yes votes. Number yes votes. And here we can't yet really define what this is, because it should always increment when you click on a button, maybe, let's say. So let's define it abstractly here. So what we are doing here is we say it's a reassignable var with a default value of 0. And so a reassignable var is just a thing that you can later assign some signal to. I hope this gets clear in a moment. So then we have the number of no votes, which is also a reassignable var of 0. Okay, and how do we compute these now? So let's do this here. So here we have these buttons and so on available. So here we say what the number of yes votes should be and no votes. So and this is done with the subscribe method. Okay, we want whenever the yes button is clicked, so this is this yes option, dot clicks. So dot clicks is an event of type unit, because whenever you click, it happens, but we don't really have an associated value, so it's an event of unit. And then there's the function called count, which counts whenever it's clicked, and you get back a signal of int. So whenever you click, the signal of int will increment by 1. So the same we also want to do for the no votes. Okay, and so far now we have the signals available in the application, and they are computed, but they are not shown anywhere. So maybe we want to display them when you click the checkbox show results. So let's do this. So we need another signal here, which says show results. And this is here with the default value false. And then here we again set this. Here we say show results subscribe show results checkbox dot. So, and this is our wrapper of the UI5 library. So here we have available, so it's wrapped like that. So in that sense, so that we have here these signals. Also the clicks was an event, so this is our wrapper that provides us with these signals. So we don't have to use observe and things like that. Okay, we want this value, and basically that's exactly when we want to show the results. When the show result, so the value is if the checkbox is checked, then it's true, and if it's not checked, it's false. And maybe then we want to display them. So here we already have some text where we can display some stuff. So let's display here with the text method. We can set the text property. And so what do we want to display here? We want to display the text, the number yes votes. Okay, number yes votes is the reassignable of int, which is also a signal of int, but we need a signal of string. So what do? We call map. And then we say I, so, and then I use this S syntax to say votes I. Okay, and probably we want the same here. Okay, let's see if this compiles. Okay, yeah, this is, so now we can, wait, why is it shown already? Okay, we just showed it now. So, but maybe we only want to show it when we click the show results button. So let's do that. So then we also have to set the visible property of these texts and basically just hide them when they're not shown. So visible, what does it take? it takes a signal of Boolean. So what is the signal of Boolean? It's the show results. Yeah, and currently we also have to tell it that it's really a signal of Boolean. Okay. So now we can click here a few times, and then now we can see the results. So, and when we click again, it's hidden again, then we can vote again. We can also vote when this is shown. So maybe we actually don't want users to vote anymore when they've seen the results, because then they've seen already how others have voted, and maybe that influences them, and maybe we don't want to allow this. So how would we do that? Okay, maybe we need some other signal, which is allow voting. Okay, should be true at the start. Okay, and now we could handle here the code that says, okay, if your user clicks but it's not allowed to vote, then we don't count one. Or we could just here in the button say, okay, we just disable it when you are not allowed to vote anymore. So let's say here, it's only labeled when you are allowed to vote. Allow voting is a signal of Boolean. Okay, and here the same. Okay, but allow voting, we didn't set the value of allow voting yet. So, what was that? I don't know, I'll just continue. So, yeah, like this. What do we want to do? We want to set allow voting. To what value should this have? So allow voting should have the value of this show results method, right? But whenever at some point in time the show results method, the show results signal was true, then we also want allow voting to stay false. So how do we do this? So first of all, we convert it to an event. So now we get an event that always happens when the signal changes. So whenever this checkbox changes from true to false, then we get such an event. And now we have this fold method. And fold works also exactly similar to how it works in a sequence. So initially, the allow voting should be true. But then whenever such a click happens, so we have the count show results. It was show results here, sorry, of course. Count show result, state, or count show result, and the last, allow voting. Okay, and to what do we want to set this? So, another bracket. Okay, so when count show result, so it should be last allow voting. So if last allow voting is false, then it should stay false. So last allow voting has to be true for this function to be true, so that's an AND. And the count show result has to be false. Okay, now this is red for some reason. There's probably just a bracket missing. Yeah, this looks good. Let's run it. Okay, now we can vote. Oh, now we can't vote anymore because we are currently showing the results. But also if you don't show the results anymore, now the voting is disabled. Okay, so we could also, of course, do other stuff like only allow some amount of persons to vote, or yeah, there's lots of stuff we could do, but we now continue with the presentation because we don't have time. Okay, so this was a demo of how our Marmolata, our library Marmolata Dive, was used together with our Marmolata UI wrapper. So actually, currently we open sourced this Marmolata Dive layer, but not the Marmolata UI layer. But you can use Marmolata Dive separately. So basically, this Marmolata UI layer just made it possible that you don't have to use these observes yourself, and the library handles that for you. So as I already told, there are some other libraries in this space. And actually, how did we start working on Marmolata Dive? So it happened about a year ago that we used MetaRx for that. And then it turned out that MetaRx doesn't have this atomicity guarantee, which I described earlier in the talk. So this guarantee that really values only happen when, not intermediate values that can't really happen when multiple things in time happen at the same point in time, wasn't guaranteed. So that's when we created this Marmolata Dive project, which at the first was just a wrapper for other libraries, so we could check what kind of other libraries. So we found a few other libraries which sounded like reasonable for us, and then we just made a common interface for them so that we could use some of them. And we made an interface for Scala.js, and Scala-React we couldn't make an interface for because it's really kind of hard to use. It's really this Scala-React is the one that was mentioned in the paper, and it's often happening in academics. So in newer versions of Scala, it's kind of hard to set up, and also there was at least no way we saw that it worked in Scala.js because of the single-threadedness and so on, which is kind of a little bit different scenario. So Marmolata Dive was then for a while just a wrapper for other libraries, but then over time it turned out that we actually also developed a backend for it, and now it's also a standalone project. But it's still, in the source code, we still have some code which supports different backends. So in Marmolata Dive we have both the signals and events, so that's a difference to for example, the Scala-X. So what we currently don't support, because it's not important for us because we only target Scala.js, is that it works in a multi-threaded environment. So garbage collection, as it turned out, when we used our wrapper with Scala-Rx, we didn't do any garbage collection because Scala-Rx has some ownership model of the signals, and we used some libraries that didn't support providing these ownerships to the right signals. So in the end, it turned out that we didn't have any garbage collection, and that's also why we then created our own backend. And what made it possible to do garbage collection for us is that we calculate the values more lazily, so that when you map some value, when you do a map from some signal to some other signal, this is really only executed, the function inside this map, when you also observe the result. And this made it possible to garbage collect the signal when it's not used anymore. Okay, and another really interesting feature are the imperative data flow reactives, which we unfortunately don't support at the moment. They are also introduced in the Scala React paper, and to my knowledge also at least none of these other two libraries support them. So what are these about? So that's future work for us. So imperative data flow reactives just give more signal construction, more ways to construct a signal. So for example, here we could have a signal that first always has the value 5, then it waits for some event to happen, which is that button 4 event is happening. Then maybe it has a value 7, and then maybe it waits for some other event to happen, which is maybe the button 7 is clicked, and then it always repeats this in the whole time. And so this means that also the dependencies of this value change over time. So first it only depends on button 4, and then it depends on button 7. And you kind of can, in an imperative way, write down what the signal should have for a value in each time. But only for this one signal. So it's then really separation of concern. Other signals are just, only interact through other signals to this. So another thing we want to add in the future are reactive data structures. So currently, when you add some value, for example, when you have a sequence of things, like in a UI, you have a sequence of buttons, or also, so currently, we just have the signal of the sequence. But when we, for example, only change maybe the second element of it, then if the sequence would be aware of the functional reactive programming, then it could only change, it could only trigger intermediate changes for dependencies for the second value. Then we also investigated a little bit what tools we can support you for debugging. So we've started working on recording the events that happen and then making it possible to time travel back and forth and see what signals had which values in specific points in time, which would make it possible to also debug undeterministic problems in the UI. And there are other minor improvements. For example, this is a syntax that Scala-X supports, but we don't yet support, and we would need some macro to support this right now. Although in Scala 3.0 or this would also be supported without a macro. Okay, so we open sourced this functional reactive programming library. You can check it out on this website. We don't yet have it on the Scala Decks because we don't yet have it in the Maven, but that will hopefully also arrive there at some point. So I hope it was a little bit clear from this presentation that functional reactive programming can make our lives easier by preventing us to have to write this event handling logic code. And then I would be open for questions. And remember to rate the session, and thanks.
Hey, thanks for the talk. How does it work with other libraries, either JavaScript or Scala?
With what libraries?
If you want to import JavaScript libraries or Scala libraries in a production environment, do you ever feel any need to import any other libraries?
In which context? Are you talking about this functional reactive programming or about more Carlos?
In the end product itself, do you ever feel you need to import some CSS library in like Bootstrap or just any JavaScript?
So we use this UI5 library, which has, so it's a JavaScript library which also has CSS classes and so on attached.
So in general,
but I mean, this Marmalata type or this functional reactive programming is kind of a general concept which can be used together with some other UI library. Or I mean, it's also not restricted to UI. And I haven't shown now this observe method, but basically you can have a signal, and when you want to have a signal that is then used in the UI, for example, to display it as a text also, you just can call observe on the signal, and then you can do the side effect you have to do, like write something in the DOM at some point or something like this. So this would be possible. And also you can check out the Scala RX, which is also similar. So if you like this idea of functional reactive programming, then other questions?